limits by conjugates. So we have here another example that says the limit as x approaches -4 of x plus 4 divided by radical 3x plus 13 minus 1. So we have to find out the limit here at x approaches -4. So always what we have to do first is try to do the substitution here, right? So this would be -4 plus 4 divided by what? The square root of 3 times -4. Don't forget the parentheses always, right? Times -4 plus 13 and minus 1. So here in the upper part we have what? We have 0 divided by what? Let's see. 0 divided by, here we have 3 times -4 will give me what? -12. -12 plus 13 would be 1. So the square root of 1 is 1. So here I have 1 minus 1. So again, I end up with an undefined expression. This is undefined. Undefined. Right? So when I get something like this, I have to try another process or another way to find out the limit, right? So in this case, I know that I cannot do it by substitution. So what I have to use here is what? Rationalization, guys. Okay, so in this case, I will have to use rationalization. So I can say that this would be the same expression times, let's change this equal to times, what? Because we don't have enough space, right? So this would be times, since the radical is here, so I have to use the conjugate of the denominator. So that would be the square root of 3x, x plus 13 plus 1, right? Divided by 3x plus 13 plus 1, because here is negative, so for the conjugate comes positive, right? Okay, so let's continue with this. This would be plus 1. Okay, so we have what? Again, we have difference of squares, but now the difference of squares is here on the denominator. So this would be equal to what? This would be, the numerator would be x plus 4 times the square root of 3x plus 13 plus 1, right? That is my numerator. The denominator would be the square root of 3x plus 13 minus 1, both terms to the power of 2. Remember, we know why is this negative here. Always will come a negative sign there because we're talking about difference of squares, and difference means subtraction, guys, okay? This would be the next step. I can cancel the power with the root. So this would be equal to what? This would be x plus 4 times the 3x plus 13 plus 1, right? Okay, so this would be 3x plus 13 minus 1 to the power of 2 is just 1, right? So this is the expression that we have. But now, what do we have here? This would be 3x plus 13 minus 1 is 3x plus 12. So here I end up with, on the denominator, I will have 3x plus 12, right? So I can factor this expression. How can I factor 3x plus 12? What do they have in common? They have in common the 3, right? So I can factor 3 times x plus 4. It's the same as saying 3x plus 12, because 3 times x will give me the 3x, and 3 times the 4 will give me the 12. But why I'm doing this? Because I want to cancel something, right? So now I can cancel this x plus 4 with this other x plus 4. So on the denominator, I have only the 3. I left with the 3. And on the numerator, I have this expression only, right? So let's move on to the next slide. And this would be what? This would be the square root, let's see, the square root of 3x plus 13 plus 1. This is equal to the square root of 3x plus 13, plus 1, right? That's what we have, the upper part, and down we have only a 3. So this is the changed form using rationalization, right? So now what I have to do is copy again the limit, right? So I ended with this part, so I can say that the limit as x approaches -4, now the new expression is the one that I have here. That is the square root of 3x plus 13 plus 1 divided by 3. Now I have to try again the substitution. So this would be equal to what? This would be equal to this. We know that this expression, we know that it will be 1 when I plug in the -4 in the x. So 1 plus 1 divided by 3. So at the end, I have that the limit